All right, algebra, unit 6. Let's talk through standard form and factored form. Let's warm up. So solve each equation mentally. I'm not really good with a mental solving, but if I look, if I look there at that first one, if I have 40 minus 8 and 40 plus n, I would think n would equal a negative 8, because then both the left and the right side would look exactly the same. Okay, if I look at this one, 25 plus negative 100 and 25 minus n, it looks like n would be a 100. True? All right. Here, I'm just trying to make the left and the right side look the same. 3 minus 1/2 and 3 plus n. I would think n is a negative 1/2. And here, looks like n would have to be a negative 6 to make the left and the right side all the same. All right, finding products of differences. So show that x minus 1 times x minus 1 and x squared minus 2x plus 1 are equivalent by drawing a diagram or applying the distributive property. Oops. That applying the distributive property is foiling, and show your reasoning. I'm going to apply the distributive property. First, outer, inner, and last. There we go. Showing my reasoning, check, got it. Okay? I hope that makes sense. If not, please text me. Okay, we can talk. If I look through this next one, for each expression, write an equivalent expression. Show your reasoning. So I'm going to FOIL these. Actually, with this one, I'm going to set up the rectangles. Again, it doesn't matter to me which one you do. And I just want to show you this is the first time we've had some negatives. So if I do multiply x times x, I get x squared, x times 1, x times negative 1, and negative 1 times positive 1. Negative times a positive is a negative. Collect like terms, I have x squared, and 1x and a negative 1x cancel out. They are gone. So that is my answer, which feels icky, but it's very helpful and very useful. We use an equation like that a lot. Okay, 2b. Let's do another rectangle. Just trying to practice all the methods. X minus 2, x plus 3, top and bottom, x squared, top and bottom, negative 2x, positive 3x, and a negative 6. I get x squared, a negative 2x and a positive 3x is a positive 1x. And we don't normally write those ones, but if you're not comfortable leaving it off, it's no big deal. And 2c. Let's go ahead and do the binomials. Now, this is such an important one. Okay, I beg you never to do this, where I just squared the first and the second one. That is so wrong. So very, very wrong, and a very, very common mistake in Algebra 1. Okay, x minus 2 squared is x minus 2 times x minus 2. Just like x squared is x times x. Okay, I have to write it twice. Now I can FOIL. First, outer, inner, and last. So I have x squared minus 4x plus 4, where I just collected those middle terms. Okay, looking through our activity synthesis, we're just modeling this with negatives. So it's really important that our negatives stick with the numbers they are. So this x times this binomial gives us this. X times x is x squared. X times negative 1 is negative 1x. And then we have that term times the same binomial, which is that here, which is all of this. All right, collecting like terms. In the middle, I get negative 2x. That comes down here and there, and we are done. All right, what is the standard form? What is the factored form? The quadratic expression x squared plus 4x plus 3 is written in standard form. Often you will see it written like ax squared plus bx plus c, where these are the numbers, okay, the coefficients in front of the variables, right? Here are some other quadratic expressions. The expressions on the left are written in standard form. The expressions on the right are not. So if I look at these, I have x squared minus 1, x squared plus 9x, just 1/2 x squared. Let's just talk through those. In this first one, I'm missing that middle term. So the bx is missing. Okay, this next one I'm missing the constant, which is the c. There's nothing at the end. Here, I'm going to keep on saying it higher level and higher level. B is 0 and c is 0. That's the difference between those first three. I keep on moving. I have 4x squared minus 2x plus 5. That one's intact. Everything's present. All right, this next one, negative 3x squared minus x plus 6. Cool, very nice equation. My first term is negative, which is no big deal. We'll explain how that's different later. And this last one, 1 minus x squared, it's in standard form, but it's not written in standard form. We always write higher order first. So that x squared is negative. That negative has to stick with the x squared, and the 1 is positive, so we can reorder it in standard form. Okay, not in standard form. This is all factored form. So everything is split up into factors. Okay, we're not meant to actually like connect the dots here. It's just the difference of, here I have a binomial and a monomial, two binomials. A monomial, a binomial, and a constant. A monomial, a binomial, and a constant, and two binomials. What are some characteristics of expressions in standard form? Okay, we've talked through this. That right there is the big one. Ax squared plus bx plus c. The term with the variable and the highest exponent, sorry, I lost that word for a second, is always written first. The constant is always written last. Okay, we go from higher power to lower power. All right, number 2, x plus 1 and x minus 1, and 2x plus 3, it's called the quantity 2x plus 3 times x. In the right column are quadratic expressions written in factored form. Why do you think that form is called factored form? Well, when we pull everything apart, we have factored things out. Let's talk about the 2x plus 3. First, I'm going to distribute 2x squared plus 3x. I just distributed that x through. Now, if I asked you guys to factor this, you're going to take out the greatest common factor from each term. That's my dog. The greatest common factor from each term. So I can factor this into 2 times x, and I can factor this into 3 times x. What's the biggest thing in common for both terms? Just an x. So the greatest common factor is just an x, which means I can factor that x out. I always factor out to the front, but I can take this out and I'm left with a 2x. I can take that out because I put it right here and I'm left with a 3. So factored form means I factored out my greatest common factor. Okay? The same goes for this one. Okay, we'll talk about factoring those a little bit later, not today. It was easier to explain with that factored form. That's it for today. Good job.